let's go. Let's talk about Hour of Code
Can we
and
tell people what the format's going to be first, Colleen?
yeah, and
Let's do
computer
that.
science with Makey Makey Scratch and Make Code. If you have never called in before, we have a chat. We want you to talk lively with us in chat. Make sure you say hello, and if you have questions, you can ask them. You can put things in Q&A, and sometimes I see them, but we actually do a pretty good job of keeping our chat active. Derek and I are not going to show slides and bore you to death. We're going to
We have some slides, and we may bore them to death at certain moments, but we'll try not.
Still bore you to death. But we are going to share some ideas for teaching with Makey Makey and MakeCode Arcade and Scratch in a casual interview style instead of just slides. So I am going to pull up the slides though right now so I can share. I forgot one other thing, but I'm going to pull up the slides right now so I can share a little bit about what Makey Makey is in case you're new to Makey Makey. And remember, if you're chatting, make sure in the little blue box it says everyone, or unless you just want to chat to me and Derek, then it would say panelists and hosts. And let's get going. And again, this will be recorded and you'll be able to watch the replay because it's going to be so riveting that you're going to want to watch it again. Right?
Always.
Okay. So there's Scratch.
Hmm.
All right. So that was the question I was going to ask, was if you're new to Makey Makey, if you would just tell us in chat. I've never seen Makey Makey before. We can spend more than 2 minutes talking about what it is, but Derek and I and the whole company, we like to call it the invention kit for the 21st century. Why is that, Derek?
Because it is so easy and it just works with everything, right? So it's basically it's creating a simple circuit to make a keyboard, and you'll probably talk more about it too, but that's why it's the invention kit, because I don't need special software, I don't need special hardware, I can just use what's in my recycling bin and start making stuff. So
I always call us like the scrappy. We're scrappy, you know, like we work with anything where we're not trying to sell you a ton of other stuff. We sell you Makey Makey, and then we're like, go ravage your recycling, go find other things that you can use to invent with. And if you don't have one, we also know that students think that they have an appealing universal design because they remind us of our old school Nintendo, which at this point, Derek and I are knowing what that is. But there's no way kids really know what that is, I guess, unless they're into retro gaming. How do kids know this stuff now? So you could you might get Makey Makey Classic by itself, that it comes with the alligator clips and the USB cable and some small white wires and this fabulous new Makey Makey sticker. Or you might have purchased a classroom set. There's 12 Makey Makeys in there, and we usually suggest that teachers use one classroom pack. And even though there's 12, we think that students work great in partners with Makey Makey. And that helps with those 180 alligator clips. I don't know how many, I just made a guess. There'd be at least 70 something alligator clips in the stem pack. How many are there?
More than that.
Yeah.
There are 144.
Yeah, see, 144 alligator clips is a lot of alligator clips. So anyway, and in case you're wondering, those alligator clips right there are hanging on a knife rack. That's an amazing way a magnetic knife rack that helps keep those organized. So Makey Makey allows you to create your own switch input. So you can see there again, scrappy, cardboard, brass fasteners, and a paper clip to make your own switch. Will you take this one, Derek?
Yeah, and so those switches, if you were looking at your computer right now, you have a keyboard in front of you, and all of those keys are switches. So if we take the idea of a single switch and we can extrapolate that out to the, 60 something keys or 40 something keys that are in front of you on a keyboard, I should know this. We can actually emulate that with a Makey Makey. And that's all it is that this equals a keyboard and mouse to your computer. So it kind of tricks your computer into thinking, hey, there's a keyboard and mouse hooked up, and then we can be creative with how we make those buttons happen.
Oh, we went too fast. I was going to show this real quick. So the front of Makey Makey, there's also the back, and you have more inputs, and we just released these backpacks. So now this one Makey Makey I can use my alligator clips to plug and play either the front or the back. And this one is WASDFG. And then I've been releasing some guides this week with Makey Max, and Makey Max has WASDFG, but also the mouse controls, like Derek said, and that confuses some people. So you can actually use it as your mouse, but you could also remap those to other things. And so the guide I put out this week, those are numbers. And that just gives you 18 inputs total that you can invent a creation with. So now,
and just so we're clear, Colleen,
Yeah.
just so we're clear, here's the back of what a Makey Makey
yeah.
looks like by itself. So Colleen, the ones that she's holding up, they're backpacks, they're boards that are attached to the back of this. So if you have a, if you get a Makey Makey and you flip it over, it should look like this.
Right. This just pops right off.
Yep.
And it's just an expansion board to allow you to use, because before you had to put tiny little white wires in here, and that's fine for adults, but maybe kids aren't as into that. So there you go. And now what are you going to do with those 18 inputs is where I think we're going to spend the rest of today talking about. And I have been saying since Derek helped us get all these great new apps out this last year, we've released 8 new apps. I think is what I just wrote this down yesterday. I think it's 8 new apps.
More than 8.
But no, that's total. But we did some in 2021. For 2022, we've done 8. So we have a lot of new apps that are really exciting, and I think a great way to push kids into coding. So I've been suggesting taking the apps and hacking them with Scratch. And now we've joined up with Microsoft MakeCode Arcade to create an extension there, so you can code with Microsoft MakeCode. And in MakeCode, you can also use JavaScript. So we've got this lovely progression of how you could go. And those are age approximations, because some people are doing coding a lot differently. Right, Derek?
Yeah. And one of the things that I want to talk about while you have this up, Colleen, is that one of the reasons why we've decided to start working with Makey Makey and apps first before jumping into Scratch or MakeCode is because it allows your students to focus on getting used to and getting comfortable with building with Makey Makey first, and being creative with how that gets used with an app, a plug and play app, before you jump into, I'm learning how to build and code at the same time, right? We want them to be comfortable with the physical invention side of things, building controllers, building interesting devices and inventions first. And then when they jump into Scratch or MakeCode, then their minds have enough space to start to learn computation and computer science at that point, rather than trying to do both at the same time. So that's kind of what you see in terms of the approach and why we use kind of off-the-shelf apps there as well.
Yeah, and I think that was the last of what I did actually have the apps to share. Let me put that back. I'm sorry, everybody. There's some of the apps right there, and we'll go ahead and share that link, but just to see, we've got the new piano app where you can adjust it, and they're just things are a little bit more changeable now. So that's nice too. They're not static apps. Kids still have a little bit of say in what's going on in there. And that's why we think they're great inspiration for learning how to create the physical hardware, but also what you're going to do next.
And I would say some of the apps too are creative apps. So like the Etch-a-Sketch, right? I can create some drawings with it. Some of them are very pragmatic, utilitarian apps. So like a timer or a counter or buzz-in app. These things are a little bit more practical in the classroom, and it allows you to be, as a teacher, to start to implement and integrate some of those apps in your day-to-day teaching a little bit more. Whereas the other ones, it's like, hey, how do I build a cool game controller or something like that? So,
well, before we go too far, then Karen just got a classroom set and has never used them before. So should we share just a tiny bit more about what we would do with our first time using Makey Makey?
Go for it, Colleen.
Or not?
No, go for it. Not now. We can spend time. Okay.
I would actually, if I've never used Makey Makey before, I would, I'm going to do this. On our website.
The web page.
Of course. On our website, I would make sure that because we didn't introduce ourselves, Derek. I just realized that. So I'll do that right now while I'm talking about this, and then I'll let you introduce yourself too. But my job is to create resources for teachers. One hat of my many hats is to create resources for teachers. And I've spent a lot of time in the last 5 years putting projects out for teachers and students and anyone who uses Makey Makey. So if you go to resources and our how-to page, you'll see right here at the very beginning, these first, I don't know, what is it, 8 or 9 guides. I will go in order. I would use this first time Makey Makey and use my hands to play piano. I would go craft a simple circuit if I had LEDs and wanted to do that. That one is actually skippable. And then I would look at what is conductive, because Makey Makey works. We said it works with anything. That's not quite true. In a way, it does work with everything, because everything in the world is either conductive or an insulator. But that's assuming you know what those things are. And that's a great science application with Makey Makey. So we learn what is conductive, what can I invent with, and what can be my insulator. So how can I make a cardboard switch, right? What about the cardboard makes it, allows me to use it as an insulator so that I can use these other conductive items on it. And then I've definitely draw a playable instrument. You've probably seen banana pianos out I like tons of banana pianos, and that's where I go. Now I'm actually reorganizing some of the slides here in the project, so I get to give you a little sneak peek. I would actually, after that, I would go and I would make an alarm. And I think that actually segues greatly into what I would do with Scratch, which we'll talk about when we get to Scratch. I can show you how to make an alarm. So alarm is down at the bottom, so we need to reorganize our apps. But I would take the alarm app just to show you how it works and plug in my Makey Makey, because that's what we should do. All right, so I'm going to plug it in and it's going to light up, and that works. And it looks like the alarm app will work when I press space. So right now, if I press space, let me focus my computer on there. So now,
thankfully, it's not playing the noise that.
Oh, boo!
Annoying, loud sound. No, don't shut the sound. It's.
It has to. It's fun. That's what. Oh, now I stopped my share. Look what you made me do.
Oh no! Can I come up with the sounds when you press it?
We need to make new sounds. We need to have the sounds be the adjustable thing. But anyway, there you go. Now you had to have it. But what I won't further confuse you, but what's great is you can actually change it to different key presses. So if I wanted to use WASD, or if I wanted to use the arrow keys instead of space, I could do that. And that's just really quick where I would go, and then we'll go ahead and we'll start talking about coding. So we're going to talk about Scratch, and we're going to talk about MakeCode. And we wanted to just sort of talk about why we're talking about those two platforms, and maybe talk a little bit about the primary differences between those two things. So you're welcome, Karen. What are you using right now? Those of you in the call, what are you using? Scratch? Are you using MakeCode Arcade? Have you only done
something else?
Yeah, are you doing something else? Or are you using Tinker? Tell us what you're doing. So in terms of layout, do you want me to show Scratch and then you want to show MakeCode?
Sure, go for it.
Okay. We are being casual. Look at this.
Erica Smith is using MakeCode. That's 1 for MakeCode, 0 for Scratch.
This is not a competition.
Oh, okay.
Just so you know. Well, I'll just go ahead and sign in and make an alarm, because I need to do something to show how this works, just to even talk about the usage. So when I'm here in Scratch, I have a lot going on. So the very first thing I see on the left are these color-coded palettes, and they are like an artist palette, and everything that's blue is a move. Here in the center, you guys can see my mouse, right? I never even, okay.
You're good.
In the center, we have our workspace where we're going to drag our coding blocks, and on the right, we have the character or sprite, which is the Scratch Cat. He's automatically the Scratch Cat that comes with everything. And here he is, and he lives right there unless I hit this trash can right here. So what I can do is, if I wanted to code with Makey Makey, the first thing I need to do is trigger an event. And I'm probably going too far already, but am I going too far? Do you want me to make an alarm?
Go ahead, make an alarm.
Okay.
I'll do something, not an
You
alarm,
can
but
make an
something
alarm too.
similar in
It would be
MakeCode.
fun to show how both of them are done. Although that's harder for yours, I think. So I get a win space clicked, and now I'm going to click over to sound. So I only need events and sound. And in sound, I already get a play sound. And honestly, the scratch cat is annoying enough to be an alarm. So now all I have to do is hold Earth and press space. And there's my alarm.
And nothing sounds more appealing than 30-something kids doing that in a room.
So another pro tip for Karen is that when you are teaching this live, because this is pretty much what I teach kids first things. Actually, I also show them like I have these printed out, and I say, what do these look like? And we notice that they look like puzzle pieces, and we put them together. And then I have them go to the sounds tab, and I show everyone, here's the sound. Doesn't it look great? Now hover over this X right here. It doesn't work as well now that it's a trash can, but it used to just be an X. And I'd say hover over this X, and then try this button on your Makey Makey. And then they delete the cat sound, and I don't have to hear the cat sound anymore. So that's how I deal with the scratch cat. So that's really simple. That's what this looks like. All the code for the cat is here on this cat. If I had another sprite, I wouldn't see any more code. I would see no code. In fact, let me add a random character. Sorry, real quick.
Colleen's jumping into object-oriented programming.
Oh, the bus ran over the scratch cat.
Scratch tours.
All right, so see, now there's no code. I go back to the cat. The cat has code. It has the code. So also his his sound is going to be gone because I deleted it. So I would have to add a sound back. But really quick, super fast. I mean, our code, we could definitely get that done, right? Now we're going to have flam snare be the sound. Oh, that's a fun alarm. All right, I'm gonna let you share what MakeCode Arcade looks like.
Okay, I'm gonna snag share screen. Oh, you need to give me the sharing superpowers.
Give me the permissions. Can you do it now? Oh, it says host only.
No, I'm good. I got it.
Okay. Got scared.
Chrome. Let's do Google Chrome. Share.
Rebecca's cat got confused when it heard the scratch cat.
Oopsies. Stop sharing. Let's try it again. Fail.
It's okay.
As Colleen says, I have the zoomies. I just need to move the bar.
Just click over. You're in it. There you go.
There we go. Okay, so makecode.com. And specifically arcade.makecode.com. So a little bit about Microsoft MakeCode. It is a programming environment for multiple use cases. So this Microsoft built this originally for programming a little device called the microbit. I don't actually have one around here. Little microcontroller unit called the microbit. So that's for programming physical hardware. This is MakeCode Arcade for programming games, video games. And then they have it for Minecraft. They have it for other products as well. So for us, we work best as a video game controller. So we use MakeCode Arcade. And when you start a project, you can create your projects here. I'll actually just create a new project and I'll call it Hour of Code. And I'm going to create it. And it looks somewhat similar to Scratch. Things are kind of in different areas, right? So I have a simulator over here to the left, and it's kind of very Game Boy looking because this is where I'm going to simulate my video game. I have drawers of similar block-based programming pieces. I have a programming environment where I can drag the blocks to. And then a number of other menu options, things like that. So I can, for example, share my game with people, and I can share a link, or I can a number of different ways to do that. I can download the game to my computer, not play it on my computer, but I can download it and save it to re-upload later. But like what Colleen did, I am going to build a really simple game. I'm just actually going to put a character on the screen and move it around. And so for MakeCode Arcade, It doesn't start with a sprite existing already. So for Scratch, you had Scratch the cat already existing. So I actually have to go find a sprite for mine. So I actually am going to go on start. I'm going to set my sprite to, and I got to go pick one. So I can draw one if I want, but I'm going to quickly pick. Oh, what do I want to be? I'm going to be this cat because we're all cat themed today. So this is my version of Scratch the Cat, and it shows up in the middle of my simulator here on the left. So here's Scratch the Cat, or Scratchy the Cat, and I want to be able to move the cat around. And so I'm actually going to move with buttons. So instead of saying, hey, when I press up, do this, and when I press right, do this, they simplified into a single block because this is about designing video games and programming video games. So it simplifies certain things. So I'm going to say move my sprite with buttons. And what they mean by buttons is I can come over here and I can actually click up, down, left, right, or I can use my arrow keys on my computer. And I am not prepared. I did not bring a USB cable for my Makey Makey.
You
but
can give
if
me
I plug in
remote.
my
Give me
Makey
remote.
Makey,
Give me remote access. I'll drive your cat.
what?
If you
No.
give me remote access, I can drive your cat.
So I can actually hit the arrow keys on my Makey Makey, and it would be the same as if I was pressing the arrow keys on this. So really quickly, I made a mouse. I made a cat that I can drive around the screen. And that is similar to, that's your kind of your 2-block program, similar to what Colleen did in Scratch. So a little different, not making a sound, but there you go. That's MakeCode Arcade.
But what's interesting is if I were to make my character move in Scratch, it would take me at least 8 more blocks. Like what you said. So it could either use if-then statements, or I could use separate when statements. So that's really kind of getting into what we wanted to talk to you about. If you want to close MakeCode and just have a quick nitty-gritty on the conversation of the difference in the purpose of these two platforms. So in MakeCode Arcade has a totally different purpose than Scratch. So Scratch was kind of designed by the MIT Media Lab. Man, it's had some years on it now. It's at least, I think it's 12 years old or more than 12 years old. It's older than Makey Makey, but not much. It's a little bit older. It's 12 or 15 years old, maybe.
Yeah, I would say, I think you're falling there right in 12, in terms of what you would think of as its current version.
Yeah. And this is like this
Scratch 3.
I wanted to say 4, but it's Scratch 3. So the first original version was like downloaded and it wasn't a web base. And then the other ones where I learned Scratch 2, which I didn't even know it was Scratch 2, and then Scratch 3 is what we all see today. And what I think is really interesting about Scratch, it's made for remixing. It was made as a place to have a community where kids would come in and they would find games that they thought were games or projects. They don't even call them games. You're supposed to call them Scratch projects. They're all projects. It might be a game. It might be a digital story. It might be an animation. Some kids make movies on there. I mean, they make amazing projects. So Scratch projects are made for remixing and getting kids to kind of have a community where they can come in and go, ooh, that was cool. How'd someone do that? I'm going to make a copy of that. And then I want to take this piece and that piece and this piece of this game and make a new game out of it, or a new project out of it. And they share animations and do all kinds of things. And they can actually make really big, complex projects. And even though a lot of times people think of it as a child or younger kid coding platform, I've seen high school students get really into Scratch because they realize they can make incredibly complicated projects. I had some seniors one year working on making an RPG in there. And they had some kids were illustrating the characters in Adobe Illustrator and then importing them into Scratch, and they were making this insane project. So that's why Scratch. That's the main purpose of Scratch. What about MakeCode?
Yeah, well, and I just to add to your kind of some of the stuff about Scratch is that I always see Scratch as like a breadth of what I can do with code, right? I can build games. It actually acts probably similar to how some of the major languages act in terms of your ability to take the blocks, take Scratch, and I can make a funky dashboard. I can build a game. I can make an interactive media experience. There's all these different things that I can do with it and plug in different products. And so
right. There's
it
all
is
the
like this
extensions, like the Lego.
Swiss Army knife of digital media. And that's what I really, really like about it. And then its ability to then easily share. I know some school districts are locking down on Scratch a little bit more, but the ability to share it and have it be a place where students can get some feedback and have a community aspect to sharing software that really does emulate the professional world, right? For those of us that make coding projects, we use GitHub and we share it and people can download it and remix my code. It is like a kid's version of Scratch or an adult version of Scratch. And that's kind of what we want it to happen, is like, how do you emulate these things?
I think actually what else you're saying is important, because Scratch is kind of made to stay in Scratch. We're not really learning to code to go out and do other things, like the Scratch community is there for you. So I'm seeing a couple of other comments in the chat, and I think it's worth talking about. People are always worried. School districts are worried about inappropriate content and games. Scratch has a great community to take down that stuff, but in case you haven't seen, and I like to show this every time because I think a lot of people don't know, you can go to Google CS First. I'm gonna have to sign in. I hope this part isn't bad. Oh, I think I signed in with this one usually. And you can access Scratch. Oh, it's the wrong one. Maybe I signed my other me in. This will be bad if it doesn't work, huh? It's gonna work. Cross your fingers, everybody. All right, so you can actually access Scratch here. I'm going to click on New Project, and now I have Scratch. Here for me, there's no community. There's nowhere for me to go find other projects. There's only building projects, and I share them with my teacher. So I think that's just a really good opportunity for schools to still use Scratch if they're blocked the main Scratch because of commenting and all of the things. Like, you can go to Google CS First. It's Scratch for CS First. It's everything you need. It doesn't have the extensions. Well, there's some. Yeah, it has some extensions, but you can still use Makey Makey without the extensions. So it's a really great free tool that just people don't seem to know exists. So I had to share that real quick. The other thing that we should talk about is like what people do when they're using them. So in Scratch, people use a lot of times for digital storytelling. My 8th grader has been using it since kindergarten to do animations and just create funny games and do contests. And it's just, like I said, it's really about the community and more about storytelling, but MakeCode is a little different.
Yeah.
So go ahead, Derek.
MakeCode is, so if Scratch is a Swiss Army knife, MakeCode, I don't know what it would be. I was going to say Switchblade, but then I'm starting to like getting the weapons. Yeah. MakeCode is designed specifically for building games. One thing, right? And it does that one thing really, really well. And it does it in a little different way. So some of those things that are really hard to do in Scratch in terms of making and programming games are like Colleen said, to program the cat to just walk around is 8 blocks. For me to program, as you saw, the cat to move around and MakeCode, it's 2 blocks. And so, but in the end, the format is a little different too, and we'll get to that. I don't want to jump ahead, but it is, and I'm going to share my screen again just so that we can go back to this, and that it actually, you can move pretty seamlessly from Scratch to MakeCode Arcade, because it is the similar blocky type thing. But I can bring in things like another sprite now, and I can set sprite 2 to, let's say, a piece of pizza. And then it shows up here, and I can move my cat around, but the piece of pizza doesn't move. But what I can do is very quickly say, set my sprite to follow my sprite. So now when it does it really fast, I need to slow it down. But what I'm getting at is that I get a lot of rich mechanics for building a game in very few blocks. So instead of trying to build this in Scratch, which can be pretty complex, kids can get further with less blocks. Now, the downside of that is that we also run the risk of saying, hey, I built this thing, and now when I go to a programming language, it should be this simple when it's still complex. So if I try to take this and go build it in Scratch, it would be more complex and it'd actually be harder. But it would probably be a little bit more authentic of an experience from programming from scratch, not Scratch, but programming from like in a text-based environment. So there's these trade-offs of being able to go further and more complex in a gaming environment, in a programming environment with that focus on gaming, because what they've done is they've wrapped a bunch of functionality into a single block. So they've simplified things down. And then I can share these games. I can click up here, share game, and I can name it, and I can say share project. And now I can share a link. So for those of you that Scratch is blocked, I can build a game. I can share a QR code so someone can scan it and play it on their phone. I can copy and send them a link. I can embed it in social media, Google Classroom, or even in a web page. So they give a lot of ways of sharing your code. How this is all saved. So if I go back to how my projects are all saved, it's through cookies on my computer. So the downside is I have to always be using the same computer for me to come back to this menu the same way it is. If I open this, and so if you have students using different Chromebooks every single day, you want them to download as a file, and then they can drag it and upload it again. So they can reopen this. They just have to go through an extra process of uploading this. One more thing is you see up here, you have a blocks option. What MakeCode is really good at is transitioning students from block-based programming to text-based programming. So you see JavaScript here. I can click on this, and now it takes my blocks and turns it into text-based programming. Here, I'll open these up so you can see what this all looks like. So this is just gobbledygook in terms of what the sprite's supposed to look like in terms of
those are the pixel colors.
Yeah, pixel colors. But you have all this text base. I can also change it to Python. So you have both JavaScript and Python that I can switch. Let's see if I can change something here. I'll change the speed of the pizza. I'll change it to 60. And I changed it in the text, and now I can go back to blocks, and you can see here that it actually changed it in the block. So I can work on both sides of block and text back and forth, and it kind of acts like training wheels for me in programming. So this is great for like middle school, if they're not getting a full-blown like tech computer science class all the time, or if they're just kind of starting out, it gives them a space to be able to start to play with text-based programming without being completely overwhelmed with it.
Will you click over to the Hour of Code slides, and we'll share the big six of like where we're going to get started, because the next thing we're going to talk about is where we're going to get started with these things. So and I'm answering something in chat. So I wanted to be on that one. I like the blocks. Just for a second. In Scratch, where we're going to get started, these are kind of all the main blocks that I would call the foundational blocks for using Makey Makey. The events, learning control, like if and else, if then statements and forever loops and all of this is a lot. So we're not going to start here, but this is kind of the goal. So now you could do the next slide. So the sprites and events are kind of the main, the first of the big six, the big thing you have to learn. I have to create a sprite and I have to control a sprite. And Derek and I have been talking a lot about this lately. And I think I didn't even know what an NPC was until I watched that movie with, was it Ryan Reynolds, where he was an NPC?
Oh,
Did
yeah.
you watch it?
Yeah.
So I think like there's some interesting gaming lingo. It works a little bit better in MakeCode to talk about that. But I didn't know before I started using Scratch that everything in the game was a sprite. Even the wall is a sprite. And so everything has to be coded. Nothing is fruitless in your project. The next thing that you really need to start looking at is sounds and looks. So with Makey Makey, I create interactive posters here because all I need is sounds to create a poster, and I could use looks to make an even more engaging poster. And then we can start getting into more complex ideas like control and loops, where I learn what an if-then statement is. I learn how to use forever loops and actually use those coding tools to make animations. And then if we want to go even further, operators will help us use logic to make games smart. So I actually kind of do this sometimes early on too, because a lot of times I challenge students to use Scratch to make projects that are really like one of my favorite things is doing STEM in the gym. So how can we create a game that, or how might we, you always have to use this if you didn't know, this is a great challenge sentence starter, is how might we instead of how do you. How might we design a game that gets kids active, physically active? And so I teach kids how to make scoreboards immediately, because then they basically just make a game that relies on scoreboards, and the computer isn't as important as the external project in that. And then we get into variables and scoring and broadcast. It looks like I talked too soon about operators and variables. And then if I have time, most of the time there's some kid who's figured out this last step. Like I don't normally ever have time when I was in the library and teaching Scratch to go this far to where I taught broadcast and backdrops, but there's always some kid who's figured it out. And then once some kid figures it out, they teach the kid next to them and so on and so forth. But by using broadcast and using backdrops, you can actually make multi-level games. Then I think that's pretty exciting. So now, what are the big six of MakeCode? Now you're going to see these are, oh, well, I'll show you some physical creations, but but you're going to see how different these two things are. I actually brought the joystick.
So the one thing, the little different from the big six that Colleen has with Scratch, big six for MakeCode Arcade is that when I teach making games in MakeCode Arcade, is that we should have and basically talk about each of the big six, but just at a different depth of level. So every game is going to have sprites, and I have to control those things. So these are the things and how I control them. Every sprite in blocks are going to use math and variables in some way. They're going to use numbers, just like I changed the speed of that piece of pizza. That's the basic entry level of changing a parameter, a number, a piece of data in my code. So it's basically, how do I use math to manipulate my game and store numbers? Music and animation, I think that's pretty self-explanatory, right? If though that piece of pizza catches my cat, what type of sound is it going to make? And what is it going to do? So part of music and animation is a feedback loop, so that I know that I got caught or that I caught something. Part of a video game is something has to happen visually to let me know, because I am not physically in the game, to let me know that I'm it, or that I lost a life, or that I win. So we have to show the player that they won or lost, or they're it. Logic and loops. This is the brains behind computer science, not just in MakeCode, not just in Scratch. This is in anything having to do with computer science. Logic and loops make your code smart. So they are very, very important. This is if else statement. And I would say the best way to teach your students the basics of logic is play Simon Says with your students. Like physically get up. You can talk about logic and you can show them videos and you can draw stuff on the board. Get up and play Simon Says with your students. Try that. And that's basically what it is the computer is Simon and is always going to win, no matter what. So you'll get them all tricked at some point. You'll have one winner, but the computer will always win at Simon Says. And when it doesn't, I guess, is when you have a error or glitch. That's what that is. Game and info is where these things like score and lives and dialogue and the end credits and the thing that says game over, all of that lives in this area. This is kind of like the structure of a game. And then scenes and tile maps are last. And this is location, 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 right? Games as story is really, really important, because then we can talk about games as literacy. And but it's literacy that I can interact with and I can be the character in. So it's like this immersive literacy if we teach it right. And so you can really connect computer science to those literacy skills, because your students, as they create games, they are creating stories. It's just now those stories have an experience. They don't have to use their imagination all the time. So location, location, location with scenes and tile maps. And that's what a lot of students really enjoy. Once they figure out how to make a tile map and scenes, they will spend hours building this little world for their little person to walk around in. And so that's, even though they are like 12-bit or 16-bit games, essentially it's a Game Boy, and something that looks like Pokemon on the Game Boy, they're going to do it for hours just because they get to build this little world that their person inhabits. So that's the big six of MakeCode. Yeah.
We talked a whole lot about coding and not very much about Makey Makey.
No.
So if you hit the next slide. Oh, not that one, but it was the next one. But
so for MakeCode Arcade and for Scratch, there are Makey Makey blocks or extensions. So we can add Makey Makey blocks specifically so that, like in MakeCode Arcade, it maps all of those, all of the inputs for MakeCode Arcade to your Makey Makey, so you don't have to change things around as much or remap your Makey Makey. Scratch has something very similar as well.
And you can make player 2 right there, which I thought was cool.
You make 2-player games.
And player 2 you can put in WASDFG and use that backpack I was showing y'all a second ago. But this is what I meant about Makey Makey is we didn't talk about the controller side, which is normally, most of our webinars are about the controller side. But I love this question that you posed the other day. What came first, the controller or the game? Because it is really kind of like, what do we do first? Do we make the game first, or do we make our Makey Makey hardware first? What do you think? What are we supposed to do?
Are you asking me, Colleen?
Yeah, I'm asking you.
So it all depends on your approach, right? Just like which came first, chicken or the egg, and we can argue about it forever. If your approach is, for example, accessibility. So if you want it, like if you have a person or student that wants to be able to, you can have a fictional person, you can have, we're building game controllers for kindergartners, whatever it is. The standardization of a keyboard and mouse does not work for everybody. And I think we can all agree on that. And so it gives us an opportunity to build custom controllers with Makey Makey so that anybody can customize a controller to play a game, whether that's Minecraft, whether that's something in Scratch, whether that is some crazy first-person shooter game. We can create those controllers for them so that they can enjoy those games. The other approach is, hey, I built this cool game. Now I can actually make a controller that fits the theme of that game, or make it custom to the experience that I want the person playing it to have with the game. So it is building an immersive experience that emulates or becomes part of the game, or inviting others into a game by designing a controller for it. That's my take. Colleen, what's yours? Uh-oh, you're muted.
No, that's why I wanted you to talk about it, because I think it's really, it does depend on the project. So in STEM in the gym, is it the controller or the game? And they're kind of honestly being made side by side, because the controller is not normal. It's not a handheld normal controller. We're controlling the game with like doing jumping jacks or doing squats or running back and forth. And so the controller is made at the same time as the game, and the kids have to kind of go back and forth between what they're doing. So I think it's a really good question to pose every time you do a project. And I think some of the fun things we've been able to do with MakeCode Arcade show like how divergent we can start thinking about controllers. And the other day you were saying, like, you know, actually all of the controllers that we see now have been designed ahead of time. They did come first, and all the games are being designed around those. And I saw the coolest thing. Do you remember? So we have a person in our educator group who posted this wild invention that they made. And then I saw this advertised to me, I think, because I was looking at all that. And it was, I think it's made by PlayStation. And it's like a thing, because mobile games are so big now. It's a thing that is adjustable, that you put on your phone. And now your phone is the display. And it looks like the Nintendo Switch, actually, but stuck with your phone. So to start thinking about how divergent we can be with controllers really introduces, I think, an exciting element to students of like, how can we invent something that hasn't been made? How can we make our own controller the way we want it to be made? And I know when I make projects with kids, it ends up being like, you know, in the beginning, it's always like all 80s type projects. We've got Dance Dance Revolution, I guess it's 90s, but Dance Dance Revolution and arcade style and all kinds of stuff like that. So do you want to show some of the controllers that we shared here?
Yeah. Do I need to go back or forward?
Oh, there we go. So I actually, you're in the right spot. I was just going to share the link to the slides so you could access all those games that Derek suggested. So there's that kayak simulator that goes with MakeCode Arcade. You paddle left and right, and your character moves in the game. And the other one is a dig dug, so you can actually dig to dig your way out, which is very different than using a joystick. So it's a really kind of a fun way to think about building your own, designing your own controllers.
And I think, so Colleen, just for a second, I think with designing your own controllers, it gives us an opportunity also to talk to students about the difference between why are all keyboards, like, why are things standardized, right? They're standardized so that I can type without looking at my keyboard, for one, but also that it's easy to manufacture. So there's like it can be replicated and easily manufactured. So there's like the business and manufacturing of like building thousands of things. And that's different than building one thing that works really, really well specifically for me. So it's like build one thing the same so that I can build thousands of things for thousands of people versus one thing for one person. Both of those have value in them. We don't want to value one idea over the other in that way. But it's like, why, you know, because we don't want to be like, keyboards are all the same, because if we all had different keyboards, none of us would be able to type. So that's one thing that I want to make sure, like when we talk about building custom keyboards, it's fun and exciting because it's personal to me, but it's not like there's a reason why that doesn't happen in the world, I guess.
You know, actually, keyboards are different in different places. Like I listened to a whole podcast about Chinese keyboards. It was fascinating. So we're running out of time, and I think we're at the resource slide next. So I wanted to share that if you haven't ever been there, you should go check out our new apps. They're great for getting your kids excited about new ideas to create. Actually, is that linked to that Scratch game? Because this is fun. We should click on it. The how-to shows all the guides, that right there. And the Makey teacher shows you how to, it's fun. The Makey teacher shows all those ones I was talking about in the beginning and how you would go in order. This is a Makey Makey prompt for brainstorming inventions. So if you hit space, it will generate a new prompt for you. So how might we make a Makey Makey controller that is surprising? Let's try another one. Involving a chair.
Ooh.
I think that one's fun. Hands free.
Ooh, a facey. Let's do it more. Ooh, rolling.
So actually the rolling, if we go back to the slides, we could show the orange. That actually is a Makey controller that is rolling.
We'll do this real quick.
Because we didn't even show that scratch one very well. So this is a rolling controller. The orange is Earth because I'm Earth. And the orange touches each conductive object to move left and right and up and down. And this is actually hooked up to the mouse and our Bubble Pop app. Then I made a little click on the side. Here is, what type of controller is this? It's not hands-free, but it's different.
It's a tilty.
It's a tilt. And so Earth is in the center on Play-Doh, and then you tilt left, right, up, down to move. And then I think the last one is this joystick again.
Yeah.
We love that Derek designed this joystick. It's so cool. The center is Earth. So even though you're moving this and you're playing with it, you're also connecting to each different washer as you go. And so all the guides for creating those are on our how-to page, and you can go and get as involved as you want in making things with.
Oh, here, I'll go back to the
Oh, you're going to go back to the last
slide? There we go. I'll leave it there while we're
and you can use the classroom slides. I'm updating those classroom slides as we speak. Hopefully they'll be ready at the beginning of the year, next year. And we love to see what you make. So make sure you share with us on social media, whatever social media you're using, Facebook, Instagram, TikTok. I was about to make one up and I couldn't even make up a name for it.
Yeah. Share your scratch games, scratch projects, I should say. If you have MakeCode games that your kids have made, feel free to share them with us. We'd love to see them. Add Makey Makey blocks to them, and we can send pictures of the controllers. We always love sharing them over social media and amplifying those things. So
yeah, and if you ever are not sure what you're doing, you can look on our page. There's a little magnifying glass, and half the time you can look it up and find whatever you need there. So we do a pretty good job of blogging and writing out cool ideas. Yeah.
And Colleen, what is our promo we're running right now for their New Year's resolution? If teachers want to know more about Makey Makey,
you should have said that first thing, and I totally
That's
forgot.
Okay. Say it again. We can say now.
Just go to the page. We're putting for your New Year's resolution. We're putting the Makey Makey Certified Educator Workshop on sale. It's $25 off, so you can join us in January to learn more about using Makey Makey in the classroom and go through using all the apps to learn how to go beyond the banana.
Yeah, that workshop includes $40 worth of materials. So it includes both of our booster kits. So you get booster kits shipped to you. And then, like I said, it's a 3-hour workshop. So you get to get the nuts and bolts and beyond with Makey Makey.
Yeah, and you get the great booster kits to boot. And that amazing fabric tape. I love that tape. All right. Thanks, everybody.
Enjoy the rest of your week.